All right, what's going on, everyone? We are going to take a look at this heads or tails problem, and it is a problem that makes good use of permutations, and it can be solved either iteratively or recursively, depending on your preference. So pick whatever flavor works best for you. So the prompt here says, write a function heads or tails. I'm just reading on this line right here. Heads or tails, which takes in a number n and returns all possible outcomes of n games of heads or tails as an array of arrays. For example, if we call this function pass in 2 here, so that means we're playing 2 games of heads or tails. And in any game, we flip a coin, we could get either heads or tails. So we can basically imagine all the different possible outcomes of flipping a coin twice, right? So if we were to flip the coin and get heads the first time, we get heads here, or we get tails, right? So we could get either heads or tails the first time, and we could get either heads or tails the second time. So all these permutations here are generated by thinking up all of the different possible outcomes that we could have from those 2 flips, right? And the same would be true if we flip the coin 3 times. We expect all the different possible sets of 3 different outcomes that we could potentially have. So I'm going to show you my solution. It's a recursive solution, and then we're going to whiteboard it out and see actually what's going on under the hood here. So here is my function heads or tails. It has within it another function which is called, and for that matter calls itself a number of times until a base case is met where it will eventually break out and return our results. So let's take a look here in my whiteboarding screen. Let me pull that up. It's on my other screen here. So I got a couple things going on here. So take a look at all the different pieces of the puzzle that we have here. We have pretty much the entirety of our screen here is what's called the global execution context. So anytime we are executing a snippet of code, we say that we're executing it in the global context. That just means pretty much everything, the entire context of the code we're running. So I have over here on the left side, I have this data structure called the call stack. And what this is it in JavaScript, it is basically a data structure which tracks the execution of our function calls via something called pieces called stack frames, which are going to sit on top of each other like a stack of pancakes, and we're going to push them on, pop them off. So that's our call stack. We have something called the thread of execution. JavaScript is a single-threaded language, which means that as we move down our code line by line, we have pretty much a pointer that's telling us which line of code we're currently executing. That's the thread of execution. We have a global, basically an area denoting our storage, as our global memory. It's where we store all of our variables, our references to functions, our objects. You can go super deep on this and talk about the heap and all that, but this is just sort of kind of a high level explanation of saving all of our moving pieces. And then I just have down here, I'm going to sort of visualize what we're going to actually print out in our terminal when we run, for example, a statement here like console log. So let's take a look through the code that we have here. We have a function heads or tails. Function heads or tails. We have down here, we are logging the invocation of that function. So let's go down line by line through our code here. So on line 250, we are declaring a function. This function is called heads or tails. So we're actually going to store a reference to that function in our global memory. So we're going to say, let's say heads. Oh man, sloppy. Heads or tails, excuse my handwriting. And what we're going to store there, we're not invoking the function yet. We're just storing a reference to what it does, right? What is the code within that function? So we're storing a reference to that function's definition here. So basically just kind of like just remembering what it does for later on. So because all of this code, right, all of this is the declaration of the function heads or tails, and within the block of it is contained the function definition, what that function actually does, and we haven't invoked it yet. We're gonna skip down to line 267 here, where we're actually going to console log out, so print to the terminal the result of invoking heads or tails and passing into. So eventually, when we figure out what does heads or tails actually return out, it's going to be eventually printed in our terminal window. So let's figure it out. Let's see what happens. So we are invoking heads or tails, passing into, so we're invoking this function, which means we're going to need to create a new function level execution context, right? We're in the global execution context. We invoke a function. We need to create a function or local execution context, right? So that's going to look something like this. And that function level execution context is going to have its own local store of memory, any variables, and let me give myself a little bit more room, any variables and things like that, which are local to that particular function's execution context. So we're going to say local store of memory. The thread of execution is going to move into that local execution context, and we need to create a new stack frame on the call stack for that particular function level execution context. Now, something that I didn't mention before too that we need to think about is because we are invoking code, right? We are running some code. Anytime we're running code, that means we're in the global execution context, which means we actually do need to denote a stack frame for the global execution context right here. And on top of it, right? So every time we create a new stack frame, we are pushing a new frame onto the call stack. So we're going to push on because now we're in the local context of heads or tails. We're going to push on a frame for heads or tails. That's going to look just like this. Right. So right now we have 2 stack frames on our call stack. So now we're inside of the execution context of heads or tails. So the first thing that we always have to do within a function level execution context is create a label for our parameters in our local memory. So the only parameter this function heads or tails has here is n. So n is going to be stored as a label in our local memory. And what is the argument that we're supplying to n, right? Because our parameters and our arguments always match up. What is the argument there? It is 2. So now we can actually dive into the block of heads or tails. So we're going to start basically running all of the code within its scope, right? So the first thing we do is we are creating a constant, right? This is a type of variable, right? Constant. So we're creating results. We're going to save that in our local memory, and that is going to store just an empty array for now, right? Nothing inside it, just empty square brackets. Now we are saving a reference to another function. We're saving a reference to a function called recurse. So we're going to save recurse, and that is going to store. Remember, we're not executing, we're not calling recurse yet. We're just saving its definition. We're saving the code of it. So we're going to save a function level execution context. We're going to save a function definition, but not quite invoke it just yet. So that is basically everything from lines 254, or rather 253, all the way to 261. So we're saving that function definition, and we can move on to line 263, where we actually invoke recurse. I'm going to grab a new color here. I'm going to grab my red color here. So we are now invoking recurse, passing in n. And what's going to happen here, right? We're invoking a new function, so we're going to have to open up a new function level execution context. I think we're going to run out of space doing it and getting successively smaller with our function level execution context within each other. So what I'm going to do is I'm going to just write it out right below it. So we need a new function level execution context for recurse. I'm going to draw that out down here. Oops. That's going to have its own local store of memory. We are going to make sure that we show that the thread of execution is going to enter that local execution context, and we are going to push a call to recurse onto the call stack. Something like that. All right, okay. So now we are within the block. We're within the scope of recurse here. We're within its execution context, we say. So what happens within recurse, right? So first we have to take care of our parameters, right? Recurse has two parameters, num, which matches up with the argument n. So because n is a primitive, we're not passing anything by reference. We're literally passing whatever n is into it. So we're just passing 2 in here. Okay. And then the second parameter here, we have what's called a default parameter. So what a default parameter is, when we don't explicitly pass it an argument, it's going to default to whatever we have assigned it to here. So here, we're not passing it, right? There's only one argument here. We're not passing it a second argument. So it's going to default to an empty array. So memo is going to default to empty array. Okay, so we've taken care of our parameters. We can actually jump into the block of the recurse function. So what it says, if, we're now on line 254, if memo length strictly equals num, does it? Does memo length equal num? Memo, right now, it's an empty array, right? So its length is 0. So does it equal num? No, it does not. So we skip the if block and we go to line 259, where we call first, let's grab a different color. We call recurse again. We pass it num. And this is interesting. We're going to pass an entire array where we're spreading whatever memo was. So we're spreading the contents of what memo is here into a new array, and also passing in a new string, heads. Okay, so we're opening up a new function level execution context. So remember, this is all sort of happening right within here. I don't know if you can see that. I'm on line 259. So everything that we're about to do is happening basically within line 259. So let me give myself a little bit more space on my canvas here. Okay. So we are going to create a new function level execution context for this blue context, reverse, passing in num and spreading memo and string heads. Okay. So in our blue context here, we have a local store of memory to make sure we show that the thread of execution is entering there, and we can push this blue call to recurse onto the call stack. Okay. So within this blue call to recurse, let's take care of our parameters. So what parameters does recurse take in, right? It takes in num and memo. So num, and what is the argument being supplied to num? It's just a reference to num, which is still just 2. And what is memo here? Well, here, remember we had that default parameter. If we didn't explicitly supply it an argument, here we actually are. We are explicitly supplying it an argument. So memo here is going to be an array where we spread into it whatever memo was in the previous context, right? In the red context, we're going to spread the contents of memo. Well, when we did that, memo didn't have any contents. So what are we spreading into it? We're not spreading anything into it. There's nothing to spread in. So the only thing else to take care of here is heads. So right now, memo is only going to be an array containing heads. That's it. That's all. Okay, we've taken care of the parameters in the blue context in this call to recurse. Now we have to check our if statement. Is memo.length strictly equal to num here? Our memo length is 1, num is 2. Is that strictly equal to each other? No, it is not. So we skip the if and we go straight to line 259, where we have another recursive call to recurse. So aptly named. So we have, what's a nice color I can pick here? How about this aqua color? So we have a call to, I hope you can see that color. Call to recurse, passing in num and spreading memo and passing in, right, line 259, heads. So let's show that down here. Recurse, num, memo, and heads. Let's open up a new local execution context. Okay. We have our local store of memory. Thread of execution enters this green context. Let's push a stack frame onto the call stack. And we can dive into the code block of recurse here, where we're going to have pretty much the same thing, right? So it's taking in num, still 2, and memo here. Now, this is where memo gets interesting, because memo here, remember what memo does. Remember what memo takes in. It's either a default parameter or an explicitly passed argument. Well, here we did have an argument, right? So we're passing it this entire array. And we're spreading into it whatever memo was. What was memo? What were the contents of memo? We're spreading those contents into this new memo, right? So we're spreading the contents, which are it's just heads. So we're spreading heads into memo here. And we have to remember to also pass in another string, heads. Okay, so we've taken care of the parameters in this green context, and let's dive into the code block. So what does the code block say here? If memo.length strictly equals num, if memo length strictly equals num, does it? Well, memo has 2 elements in it, and num is 2. So yeah, that actually checks out. So let's see what happens inside of that if block. So inside of that if block, we are going to push into results whatever memo is. So let's take care of that. So whatever memo is an array of heads, and heads So let's push that into results. What is results? JavaScript looks here for results, right? It looks in the most local execution context first. Does it see results there? No, it doesn't. So it looks down the stack frame, or down the call stack, one stack, or one call out, right? So it looks in the blue context. Does it see results here? No, it does not. So it looks in the red context. Does it see results here? No, it does not. It looks in the black context. Does it see results here? Yes, it does. So we are going to push into results. Remember, we're pushing into results what memo was, an array of heads and heads. So I'm going to need a little bit more space to actually display what results is. Let's do it up here. I want my black. Yeah, let's say results. This is totally independent of what's to the left of it. Results is going to be an array. And now we're pushing into results an array containing heads and heads. Okay, so that now exists in results. So we're still in the green context, right? We're still in, let me grab my green color again. We're still in the green context. We're still in the block of the if statement here. So we just ran line 255 here, and now the only thing left to do within that if block is to return. Just the keyword return. So we're returning out of that execution context into the stack frame below it. So we're returning out of this green execution context, which means we close out of this execution context. JavaScript garbage collects that, it's gone. We pop that call off of the call stack, and JavaScript goes one level out into the blue execution context. So it kind of goes back into the blue execution context. So now we are back in the blue execution context. Let me grab my blue pen again. So remember where we were in the blue execution context when we called this green call to recurse. When we did that in the blue context, that was line 259. Now we are on line 260. So we are, once again, invoking recurse. So we're going to need a new color. We need a new color. Let's go with orange here. So we are calling here, it's more of a brown really, num and spreading memo, except this time, as an argument, we're passing in tails. Tails here. And we are opening up, right, because we're calling recurse again from within itself. We're opening up a new execution context. I'm going to draw it over on this side here. Let's draw it right here. So this is going to be my execution context for recurse, passing in num and spread memo in tails. Okay, so this has a local store of memory where we are going to assign our parameters to labels. So num, still going to be 2. Memo is going to be, what are we passing it? We're passing it an array. Sorry, this should be square brackets here. Passing it an array where we're spreading into it. Spreading into it whatever memo was. What was memo? It's just heads. So we're just spreading in heads. Heads and tails. Okay. So now we're in this sort of orangey brown context. We're within the block of the call to recurse, and we hit this if block here, right? if memo length strictly equals num. Does it? 1, 2, 2. Yes, it does. So we enter the block of the if statement. What happens in the block of the if statement? Results push memo. What is memo? Memo is an array containing heads and tails. Where is results? Well, we remember results is all the way back here up in the black context. So we are pushing into results an array containing heads and tails. Okay. So that is the completion of line 255. We go to line 256 where we return. We return out of the Brown context. So this gets closed over. It's garbage collected by JavaScript. Actually, I never showed it really, but we did have a call that was pushed onto the call stack for this Brown function level execution context, and now we pop it off. And we return back out once again to the blue execution context. So now we're back in the blue execution context. We have just run line 260. And what happens after that? That's the end of that function. There's no, right? This pink square, this pink curly brace here matches up with this. So that's the entire block. That's the entire block of that function in that blue context. Let me get my blue pen back again. So that's the entirety of the execution context of the blue function call to recurse, right? So we close out of the blue context. JavaScript garbage collects that. We pop that call off the call stack and we return back out. Oops, we return back out to the red context. So we're back in the red context here. What was the last thing that we did in the red context? We ran this call to recurse, which was line 259. Now we have to run line 260. So let's see, what's a good color we can use here? Maybe, maybe more of this light blue color. Yeah, it's too similar to the other blue. How about pink? Let's go with pink. So we are calling, right, line 260, we're calling recurse, passing it num and spreading memo, and we're passing tails. So we have to open a new pink function level execution context. I'm going to run out of space down here. We have a pink context, has a local store of memory. Thread of execution enters the pink context. We create a pink call in the call stack. So what are we passing it? We're passing it num and an array of memo and tails. Recurse num and an array of spreading memo and tails. So let's take care of those parameters. We have num, which is going to be still just 2. And we have, what was it called? Memo, which is going to be an array where we spread into that array. We spread in whatever memo was, right? We're coming from the red execution context here. What's in memo? There's nothing in there. So we have nothing to spread in. So we just pass in tails. That's it. So this gets passed in tails. Okay. That takes care of our parameters. We enter the block of that function. So we enter the block of the function recurse here, and we check this if statement once again. Is memo.length strictly equal to num? Well, memo only has one thing in it, so its length is 1, so it's not. So we skip the if block and we go straight to line 259 where we have a call to recurse. So we're going to need yet another pen color. Let's go with this blue now. Okay. So we have a call on line 259 to recurse. Recurse, passing in num and an array containing spread, memo, and heads. So we are going to, I'm going to need more space down here once again. All right, let's give myself a little bit more space. Oop, I don't like that. I don't like that. I need my background color to be white. I don't want a brown colored canvas. Okay, got a little bit more room here, got my blue color. We have a call to, can't spell this, recurse, num, spreading, memo, and heads. We open up a new local execution context. It's got a local store of memory. We're going to take care of, let's see, the thread of execution context. Thread of execution enters the blue context. We push a call to the blue context onto our call stack. And we have to take care of our parameters here. So we have num, it's going to be still just 2. We have memo, which is going to be an array containing, spreading whatever memo was into it. What was memo? Just tails. So we add in tails. And we push in heads. Okay? So now we jump into the block of the if. We check the if conditional statement. So is memo.length strictly equal memo length, is it strictly equal to num? Yes, it is. So we jump into the block of the if. So what do? We push into results whatever memo is. What is memo? It's an array of tails and heads. So we push that into our results. Tails, heads. And I don't think I'm going to fully diagram out the very last call, but you can imagine what would happen if we went the second route here. Basically, right, we did everything here. Now we would have to take care of line 260, where we would pass in tails instead of heads, and we would eventually have something getting passed into results where we would have tails and tails. At which point we would basically exit all of these contexts, right? These get popped off. We're back in the red. The red will have run its course at that point. We'll be back in the black. And back in the black context, so remember where we were in the black context, we had just run this line right here, line 263. That's our call to recurse, passing in n. So that's done. That line has been run, and now we're on line 264. So the only thing left to do here is return results. What is results? It's all of these values right here. So we return the accumulated value of results back out into the context in which it was invoked from, heads or tails. Where did we actually invoke that? Well, we invoked that on line 267 here in our call to heads or tails, passing in 2. And all we're saying to do there is log to the terminal, log to the console, that output. So what we'll end up seeing in our terminal output here is an array of arrays. right? So we'll end up seeing heads, heads, tails, heads. This might not be the right order, but you get the idea. Tails, heads, heads, tails, and tails, tails. So we see that in our terminal at this point. When we returned out results from our black context, right, our call to heads or tails, that function has run its course, it's closed over, it's garbage collected, and we can pop that call off the call stack. Now, after we have console logged out the result of invoking heads or tails, all of our code has run. We're no longer in the global context, and that will actually pop off the call stack as well. So that's it. Okay, that is my solution for heads or tails. Any questions, feel free to leave a comment and I will respond to it. And I hope that this helps you kind of visualize permutations which come up pretty often in interviewing situations. So yeah, let me know what you think. Comments, questions, suggestions, I will check out, and have a good day.